All right, so I want to talk about what a software engineer needs to know about characters. I've been surveying some people that are just out of college, asking, in college you learn about two's complement, floating point, mantissa, all that stuff. But it turns out a lot of people aren't really taught about characters that much or about what Unicode is. And that's kind of annoying because software engineers deal with characters quite a bit. So I want to make sure, and there's a lot of things about what a character is that's a little bit more confusing than you might think at first. I'm going to just kick that off by starting with an example of just determining the length of a string. So here I have a string called or named the French word fiancé, and it has this little e here with the acute accent. And the length of that string is 6, and as you can see, this is in Java strings are UTF-16. I'll get into that a little later. And it just maps a number to each character going through here. And you can see that little e with the tilde with the cute over it is E9. So this so far is pretty straightforward. So what about this? How many characters do we think this one is? Well, you probably are suspecting it's not 6, by the way I asked that question. And that's true. So for this case, we're actually using a combining diacritical mark. So there's the E, and then there's a little acute there. And this is actually of length 7. F-I-A-N-C-E, and then combine the diacritical mark with the previous letter, and then that gets this. So here's the thing, when you render it, it's actually going to render as 6 characters still. But but if you actually do a string length in your code, it's actually going to tell you the length is 7. So that's maybe a little surprising. Maybe a lot of people didn't know that. So let's go to this one. How long do we think this one is? This one is actually length 5. So I managed to put this word in 5 characters. So how did I do that? I actually used what's called a ligature for FI. So we actually got this down. So how many people thought you could do that I could get this word in 5 characters? Probably that's probably surprising to a lot of you.
This is only a problem with French.
So yeah, those French. So, and this I wanted to start with an example that just kind of illustrates that a lot of assumptions you may have about how strings and characters work may not be true. So finally, I'm going to, so the last example, I'm just going to throw out the tilde on the E. I'm just going to go with the regular word and see, let's see how big this one is. This one is 12 characters long. Okay. So why did I do that? Well, it's because I'm actually not using the ASCII characters. I'm using the mathematical alphanumeric symbols. And what that does is, in UTF-16, we have, is not a fixed size code set. So here we have all the characters are 2 bytes long in UTF-16, except some characters take up more than 2 bytes, so they have to split it into surrogate pairs, so low surrogate and high surrogate. So these two combined make that F. And then, so if you tried to render a character individually, you would just get a question mark. And that's actually what I am doing. I'm actually rendering the individual characters on the screen. It's rendering as these question marks. And that's because what the browser sees is, well, that's half a character. That's half of a surrogate pair. I don't know what to do with that, so I'm just going to put a question mark because I can't render this without all rendering that. Without also knowing I only have the high surrogate. I can't render that unless I also know what the low surrogate is. So hopefully that gives you the idea that there's actually some surprising behavior of characters. So I go into a lot of character terminology here, and I have a companion YouTube video where I just go through and I read every one of these. I'm not going to do that right here just for time reasons. If you want that, just look up Discourse. I've got a link to the YouTube video where I do that. But I do want to focus on this one. Is for technical people, when they're talking about a character, they're usually either referring to a code unit or a code point. So code unit, that is what you're getting with string.length. You're actually counting the code units. with a code point, that's actually the actual character. So if I go back to this example, this high surrogate is a code unit. The combination of the high surrogate and the low surrogate, that's the code point. So that's what technical people are usually referring to when they say the number of characters is something. Either what a string.length gives you, which is the number of code units, or the number of characters that those code units represent, which is going to be the number of code points. Now, from more common language or business people, they're usually referring to a grapheme or a ligature, and that just means one distinct thing, essentially. I got some fancy terminology here. It's a contrastive unit of a writing system. So a C is the same as any other C, no matter how it's written. And then also glyph refers to just how it's rendered. So there can be many glyphs that represent the same C, but it's only one grapheme. So one C is the same as other, no matter which glyph you use. I already kind of went into ligature. And I'm going to gloss over these. If you want more detail, go ahead and look in my YouTube video attached. But I want to get to how this can affect the way you code. So look at the Java code here. We have a file reader. We're newing it up, and we're reading README. So file reader actually reads characters. So in the README, but here's the thing. I never, on the file system, what you have is bytes. So Java has to actually convert the bytes to characters somehow. And this is the most important thing you need to understand about characters, and I think I even say it twice here, is you cannot convert bytes to characters or characters to bytes without the encoding. So the encoding is just it's just the rules for converting between bytes and characters. Is essentially what the encoding is. So when you see this code here, you see, oh, I'm getting characters because this is a reader, but I don't have an encoding. So that should tell you that something's up. Something's going on that you're not seeing. And what you're not seeing is that this is actually using the default encoding. So if you dig into the source code, let me make this a little bigger, you'll see it's doing something equivalent to this. It's actually creating a new file input stream. Now stream reads bytes, and then it wraps it in a stream reader, so convert bytes to characters, and here's the char set it uses, and if you look at the code, it actually just grabs the default char set. So that's significant because if we're grabbing the default char set, that means that we are not platform independent. That means on one platform, another platform, this code isn't write once, won't run anywhere. It'll behave differently depending on what the default char set on where you're running it happens to be. So what I usually do is, now that's rarely what you want. Sometimes you actually might want to need the code to behave differently on different platforms, but usually not. So usually what I try to do is instead of using this default char set, I just go to standard char sets and just choose UTF-8. So UTF-8 is nice because it's one of the UTF encodings, and you can represent any Unicode character with any of the UTF encodings. So right now, I'd like to go over the difference between UTF-8 and UTF-16. So in Java and in Haskell and in most languages, strings are in memory represented as UTF-16. So that we already saw on my example over here. However, on disk and mostly on the web, you usually represent stuff in UTF-8. So the advantage of UTF-8, it's a variable length mapping. So the most common characters, for example, every character you see here, only take up 1 byte each. And it only takes up more than 1 byte if it's a more obscure character. So that's an optimization there. So let's see. Okay. I think
You do not need to know the character set already for the file that you're reading in, or you can use any character set? Like when
you have to know already.
You need to know already, okay.
So we don't typically notice this because if most of your characters are just the standard ASCII characters, there's a lot of character sets that are compatible with that. So for example, UTF-8, it can't tell the difference. If you're just using characters 0 through 127, it actually ASCII happens to be the same format as UTF-8, and that's why you don't notice. But yes, you do have to, there's nothing on the file that tells you what character set it is. So you just have to know. And that will lead me back. So let's look at HTML documents. So how do we specify a character, an encoding? And this is one thing that Java kind of annoys me with, is they call it char set, and it's really not char set. What they mean is encoding. The char set is just a set of characters that are represented by encoding. So, but they call it char set, so just remember anytime you see char set, usually what they're referring to is encoding. So here, how do we specify the char set in a HTML document? Well, we've got this meta tag that specifies the char set. So to your point, how do we tell what char set the file is in? We just read it, in the case of an HTML file, read it right out there. So, but remember that the HTML file is transmitted in bytes, not characters. That's transmitted over the internet protocol. So what's the problem with this? Does anybody see the problem with this?
You have to parse the document and you don't know what the character set is.
Exactly. You have to parse the document to know what the character set is. But you can't parse the document until you know what the character set is. So
This is meant for.
We'll deal with that in HTML set.
yeah. So something's up, right? So that should tell you something's up. And if you're not, and that's the thing with the software engineering in general, when you see stuff like this and you don't understand it, you need to learn something. Don't just gloss this stuff over, because something's going to burn you in the future. So what actually happens here? Well, I looked up in the HTML specification, and so what it does is it has this rule in here that says the character encoding declaration must be serialized within the first 1,024 bytes of the content of the document, and it uses ASCII for that. So your first 124 bytes have to be compatible with ASCII. The whole document does. Now UTF-8 works because it's compatible with ASCII, but not all Unicode character sets are. So that's something that if you have the whole document in something other than ASCII, that is something you got to watch out for. And I actually pulled this from the Mozilla site, and they were actually talking about this has actually caused a whole bunch of security problems with certain character sets. So they say just avoid these character sets because they've actually been burned with these character sets because browser's not supporting them, interpret benign content as HTML elements. So this has actually burned people, this idea right here. So this is why most documentation I've read just recommends for the web, just use UTF-8 for everything. You could also use this ISO 88591. That's actually the default, and that's the only reason I note it here. So that's something, again, a little more complicated than you might have thought. Stu?
But I think you can also express the encoding in the content type header with HTTP. I know it's optional to do that.
Right.
For the HTML type, you can. I guess I don't know if browsers use that to work around some of those security things.
Right, and they may. So I was actually talking about an HTML document. But yeah, that's true. I'd have to look into. I actually have not looked into that yet. So how am I doing on time?
You have 1 minute.
Okay, perfect. So I have an example where I actually take a bunch of UTF bytes right here on this G-clef symbol. There's the G-clef. And I go through and I show step by step how to take these bytes and convert them into Unicode code byte, into its Unicode code point. And I just demonstrate how to do that all the way through. So I don't have time to go over that now. What I will say is with UTF-8, if you see a byte that starts with a 0, you know it's one of the ASCII characters. If you see a byte that starts with a series of 1s and then a 0, you know the number of 1s is how many bytes long you are. So that's 2 bytes long, that's 3 bytes long, that's 4 bytes long. If you see a 1 and a 0, well, by that pattern, you would think that's 1 byte long, but we've already covered the 1 byte case. So if you see a 1 then a 0, that means you're in the middle of a Unicode, that you're actually in the middle of a character. So what a rendering engine will do is that if you start parsing if you start scanning right here, what it'll do is it'll just start skipping these 1 zeros until it finds something that it knows is at the start of a character, and read that. And for details, if you want to see the app, I go into this in great detail in the video that I posted on Discourse. So if you want to see the details of how this works, just check out the video I posted to Discourse. That's it.